Hello, we are on 2.04 pre-calc notes today, which is polynomial division. And we've done this a little bit in A2 last year, and most of you guys were pretty good with it. So hopefully you are reminded of how to do it when we start going through it. A couple little extra things that we'll add on as well. So the first one I want you to do is consider the graph of f of x equals negative 19x squared plus 6x to the third plus 16x minus 4. So first I look at that and I say, okay, well, that's not in standard form because the highest exponent doesn't come first. So I'm going to rewrite it with the highest exponent first, so 6x to the third, and then descending. So minus 19x squared plus 16x minus 4. I want you to go to your calculator and look at the graph. So go ahead and type that into your calculator. And I want you to find an obvious zero value. Obvious zero. So in my calculator, we're going to do y equals and type this in. So I have 6x raised to the third minus 19x squared plus 16x minus 4. And let's zoom 6. So we get a nice graph here. We can see that it looks like it's hitting the x-axis here where it's tangent to the x-axis. So it would have an odd multiplicity. And here, or rather, sorry, an even multiplicity. And then here where it's crossing through the x-axis, it would have an odd multiplicity. I want to find one of those numbers. So this one looks like it hits a little bit before the 1. So this one looks like it might be at 2. So I'm just going to verify on my table and see if I have any zeros in there. So at 2 right here, you can see I have the point 2, 0. So looking at this, I know that I have a 0 at x equals 2. Now, I want you to tell me based on that fact, on that root, so based on part A, what would be a factor? So if our 0 is x equals 2, a factor, think when you factor something, you put it into parentheses, you want to have the factor that would give you x equals 2. So in your factor, you would have the opposite sign. So it would be x minus 2. And then if you set that equal to 0, it would give you x equals positive 2. So the factor, think factors, parentheses, roots are x equals or 0 or x equals. So again, we just took a look at this graph, something like this, and we're finding this root right here from our calculator. We said we checked on our table, it met at 2, 0. So we know that a 0 is x equals 2. The factor then, based off of x equals 2 is our 0, would be x minus 2. And part C, determine the quotient q of x by using long division. Oh yeah. Then find all zeros. Okay, so for long division, we're going to take our original here. So we have 6x to the third minus 19x squared, our original but in standard form, minus 4. And we're going to divide that by our factor, so x minus 2. So you always are dividing by the factor. All right, so next what we're going to do is we're going to look at your x and say, how many times does x go into 6x to the third? Or x times what gives me 6x to the third? Well, 6x squared. So I'm going to find my x squared term right here and write it right above that. So 6x squared. Now I'm going to distribute and multiply through by that term. So now I have 6x to the third minus 12x squared. And then remember that you want to, sorry, I'm just also plugging in my computer at the same time. You want to switch the signs on that teal polynomial because you're subtracting the entire polynomial. You want to make sure you change the signs of both of them. So distribute the negative. So negative, and that becomes a plus. And now we're going to add straight down. So we have negative 19 plus 12 would give us negative 7x squared. These cancel, and then you bring down the next one. So plus 16x. Again, we're only looking at the x. X times what gives me negative 7x squared? That'll be negative 7x. Then you distribute. So I have negative 7x squared plus 14x. And then we change our signs. This becomes plus, this becomes negative. So I have 16 minus 14 gives me 2x. These cancel. Bring down my next term, which is a minus 4. Now again, I'm looking at this x. X times what gives me 2x? Well, x times positive 2. Then I distribute. So I get 2x minus 4. Change my signs. This cancels. I get 0, which tells me x minus 2 is indeed a factor, which I already figured out from my calculator, but now I verified that algebraically. But I want to find all of my zeros. So now I know I've got this 6x squared minus 7x plus 2. So I'm going to take that because I know that times x minus 2 gives me my original. So I want to factor this using p's and c's. So my p would be 12, my c would be negative 7. Make it into 4 terms, blank x plus 2. And we've got our two numbers would be negative 4 and negative 3. Group them up. And again, you guys should be able to do this on your own. This would be a good place you should have paused and done it yourself and then check the answer. So I've got 2x times the quantity 3x minus 2. Take out a negative 1, leaving me with 3x minus 2. Regroup to get 3x minus 2 times 2x minus 1. So now I've got two things. I can tell you my complete factorization. Complete factorization just means break it down into your linear factors. So I have 3x minus 2 times 2x minus 1, which I got from right here. And then I also have my other factor that I divided by, which was x minus 2. So let's say call it f of x. So f of x would equal that. That's complete factorization. Now I asked you here for your zeros. So your zeros are just if you set each of these factors equal to 0 and solved. So we'd get positive 2 over 3, positive 1/2, and positive 2, which we came up with from our calculator again. Also double check you have 3 zeros. Our highest exponent is a 3, so that matches up. It should always be the same as your highest exponent. All right, now let's review our synthetic division. So synthetic division, if you remember, is like a shortcut for long division. A shortcut for long division. The only issue is we can only use it if it has an x minus k. So only works if your divisor or what you're dividing by, for divisors in the form of x minus k. So x minus a number or x plus a number. So, or x plus k, because that's just x minus a negative k. Remember also some little things to remember here, your vertical pattern. So going down, think that makes verticals like this. You can make a plus sign out of it. You're going to add. And anytime you're going diagonally, think of a diagonal line, and we can make an x out of that for multiplication. So in general, our form here is if we have our coefficients a, b, c, d, let's say, and then you're always going to put your root on the outside, where long division is your factor you're dividing by. Here we divided by the factor. Synthetic, you're dividing by just the root, so that should have the opposite sign of what's in the factor. And first we bring down our a, and then so that's going down, and then we go up, so that's our diagonal, so we multiply a times k. You're always multiplying by this number out here on the outside. Then we're going down our vertical pattern. Think you can make a plus sign from the vertical, so you would do b plus a k. And I'm not going to continue with the letters because I think it just gets really confusing. But again, you're just going multiplying, going up, adding, going down, multiplying, going up, adding, going down. And then this last number you get right here, that is always going to be your remainder. And then in here, that tells us our coefficients of our quotient. All right, so we've talked about all this before, so let's kind of dive right in to an example. So number 2, use synthetic division to divide x to the 4th minus 10x squared minus 2x plus 4 by x plus 3. So x plus 3, that would give you your factor. Also take note here, we go from a 4 exponent of 4 to a 2, so we need a placeholder at x to the 3rd. Okay, so we would have our coefficient here. So this would be like plus 0x to the 3rd. So I've got my coefficient of x to the 4th is 1. My coefficient of x to the 3rd is 0. X to the 2nd, the coefficient is negative 10. X to the 1st, negative 2. And then my constant is 4. Make my box. On the outside over here, so we're dividing by x plus 3. So if x plus 3 is our factor, we want the root, which would have the opposite sign. So it would be like if you took your factor and set it equal to 0, you would get x equals negative 3. That's our root, or a 0. So negative 3 goes on the outside here. So first step, drop it down. Just bring that 1 down. And then we're going back up. So now we're multiplying. 1 and always multiplying by this root out here. So 1 times negative 3 is negative 3. Then going down, so we're going to add 0 minus 3 is negative 3. Going back up, so we multiply by the negative 3 to get 9. Add going down, we get negative 1. Multiply going up, we get positive 3. Add going down, we get positive 1. Multiply going up, we get negative 3. Add going down, we get a positive 1. Last number here tells us our remainder. Since I have a remainder here, that tells me that x plus 3 is not a factor of that original polynomial right here. So negative 3 is not a root. So my answer, I can't take it any further to find any zeros or anything like that. I would just have my answer here, and remember it should always end up being 1 less than your highest exponent here, but the last number here is your constant. Then add your, I'll put that in a different color, add your x squared, x to the 3rd. So our answer would be 1x to the 3rd minus 3x squared minus x plus 1, and then you add your remainder over your factor. So x plus 3 would be our final answer. So remember this part at the end again, you take your remainder over whatever that factor is that you're dividing by there. So your divisor. And that's it for synthetic division. Okay, number 3. Actually, before number 3, refresher of remainder theorem. So remainder theorem is a quick way for us to figure out if something is a factor and if it has a remainder and what that remainder is. So if a polynomial, let's say f of x, is divided by x minus k, the remainder is f of k, whatever this is right here. So f of k. So the remainder equals f of k. So quick example here. I want you to use the remainder theorem to figure out the remainder, to find the remainder when p of x equals x to the fourth plus 4x to the third plus 3x squared minus 7x minus 25 is divided by x minus 4. Okay, so I could do long division. This is in the form where I could use synthetic division because it's x plus or minus a number, but those are all going to take me quite a while to do. All I want is the remainder, so I'm just going to take whatever, this is my factor, I want to find my root, so my root would be x equals 4, so I'm going to take p of, this is a p, so p of 4, and substitute it in, so I'd have 4 to the fourth plus 4 times 4 to the third plus 3 times 4 squared minus 7 times 4 minus 25. Type that whole thing into my calculator, and it gives me 507. So that would be the remainder if I were to divide the two polynomials, which means x minus 4 is not a factor because it would not divide in evenly into p of x. So if it is a factor, your remainder should be 0, meaning it goes in evenly without a remainder. So since we have a very large remainder here, that tells us that it is not a factor. Okay, we're going to do one more problem together. I'm going to start on a fresh sheet here. Show that x minus 2, and this is a longer problem, which is why I want to start on a new sheet, and x plus 3 are factors of f of x equals 2x to the fourth plus 7x to the third minus 4x squared minus 27x minus 18. After you do that, we want to find the remaining factors of f of x. So write out the complete factorization, which means just write out all the linear factors. So write out complete factorization and list all the zeros. In this case, they'll all be real zeros. Okay, so first I've given you two different factors here. So x minus 2 and x plus 3. So let's start with x minus 2. So I want to break this down. So I'm going to take my original and I'm going to show that that's a factor. So I'm going to take all my exponents, make sure my exponents count down by 1, so I don't need any placeholders. 4, 3, 2, 1, 0. That's good. So I take my coefficients. I'm going to use synthetic here because they're both in the form of x plus or minus a number. So I take 2, 7, negative 4, negative 27, negative 18. On the outside, I'm just focused on this one right now. That's my factor is x minus 2, so my root would be positive 2. Again, parentheses, if it's x plus or minus a number, it's your factor. to set that equal to 0 to find your root. So first we bring down our 2. Again, we're always multiplying by the number out here. 2 times 2 is 4. 7 plus 4 is 11. Actually, pause the video here, finish this, and then check it with mine. Okay, I'll write this out. 18, 36, 18, and 0. So we have a remainder of 0, which means good news, x minus 2 is a factor because there's no remainder. Now I want to check x plus 3. So I'm not going to, if I put it into the original again, I'd again get a remainder of 0. But that's not our only goal here. We want to find the rest of the zeros, so we need to break this down as far as we can. So what I'm going to do is take this now, and I'm going to put the negative 3, since my root factor was x plus 3, my root is negative 3. And I'll just rewrite it, 2, 11, 18, and 9. And I'm going to make that my polynomial that I'm going to put negative 3 into, again, using synthetic division. And sometimes people even just to shorten it a little bit. I'll show you a little shortcut here. It's okay if you already wrote that. Some people just go like this, so they don't rewrite it, and continue. So then we bring down our 2. Again, pause the video, do the synthetic on your own, check to make sure you get the same answer. Again, you should get a remainder of 0. Great news. Now we've just showed that both of them, so x minus 2 and x plus 3, are factors, because it asked us to show this, because they have a remainder of 0. Now I've also broken down this polynomial into a much simpler polynomial. So again, your exponent, highest exponent should be 1 less. So here it's 3 is your constant, then we add an x, then we add an x squared. So I have 2x squared plus 5x plus 3. I want to write the complete factorization, so I want linear factors, and I also want all my zeros. So I need to now factor that polynomial. So I'm going to use P's and C's to do that. Pause the video, do your P's and C's, and then check back with me. Okay, so you should have gotten x plus 1 times the quantity 2x plus 3 for your 2 factors. So that tells us now our complete factorization would include our x plus 1, let's say f of x equals x plus 1, 2x plus 3, and then the ones that were given to us, which was x minus 2 and x plus 3, which is how we got the x plus 1 and 2x plus 3. We had to use those 2 factors to break down our polynomial into something more simplified. So that's our complete factorization. And then our zeros, it asked you to list out all the zeros. We know from the givens that 2 is a 0, negative 3 is a 0, because they gave us those factors and we verified that those were factors by finding they had a remainder of 0. And then you'd want to set these 2 equal to 0 as well. So we'd get negative 1 and we'd get negative 3 over 2. Again, double check. We have 1, 2, 3, 4 zeros. Our highest exponent, too far, is a 4. So that means we should have 4 zeros. In this case, they were all real numbers. Okay. All right, and that is it for our 2.04 today. Hope you had fun. This stuff is really fun, I think, but I hope you enjoyed doing it as well. And if you have any questions at all, please let me know. Pi out.